Assalamualaikum to Dr.Naziatul, Aziah. My name is NURSHABILA Binti HALIM with matrix number H2OB1634. First, I will explain part A. We had been given to research about labor force by two age group, which is 45 until 49 and 50 until 54 in Kelantan 1982 until 2019 in 1000. We are given an appendix 1 for our data set to get a random sample above than 50. We discussed to get the random 72 sample from the appendix 1. We put our data set into the table and the maximum entry is 72.7 and minimum entry is 21.9. We calculate and find our class that is 7 and class width which is 8. Next, after we got the class and class width, we construct into appropriate tables that can be used to describe the data. We find our type of data is group data. First table is frequency distribution, which has class that refers to data entries in each class, and frequency refers to the number of data entries in the class. We put our data into the classes and find the frequency of 72 samples. Second is relative frequency. Same goes to frequency distribution, but at relative frequency and cumulative frequency, we calculate the relative frequency and get the total number of 1, while cumulative frequency is same goes to frequency, which is 72 sample. We calculate all the data neatly and organized. The graphs are suitable to use for quantitative variable data have 3, which is histogram, frequency polygon, and OGIF. So we choose 2 that suitable in our assignment, which is frequency polygon and OGIF. A frequency polygon is a line graph that emphasizes the continuous change in frequency. The following properties must be followed. First, the horizontal scale is the midpoint of the data value. Second, the vertical scale measures the frequency of the class, and the last point that represents midpoint and frequency of each class and connect the point in order from left to right. Frequency polygon must be closed, so we need add 1 for the first class and add 1 for the last class. Next is OGIF. OGIF is a cumulative frequency graph, or OGIF is a line graph that displays the cumulative frequency of each class at its upper class boundaries. For OGIF, we must construct frequency distribution that include cumulative frequency of the column. Second, we must specify the horizontal and vertical scale. For horizontal is upper class boundaries and vertical is cumulative frequency. Third, we must plot points that represent the upper class boundaries and their corresponding cumulative frequency. Next, we must connect the point in order from left to right. The graph should start at the lower boundary of the class, which is cumulative frequency is 0, and at the upper boundaries of the class, which is cumulative frequency is equal to the sample size. From the OGIF, we can see the graph start at 22.3, where the cumulative frequency is 0, and the graph end at 78.3, where the cumulative frequency is 72.
Assalamualaikum. My name is NAZIRAWANI Binti ZARIEA. My matric card number H2O1338. The mean is the average. The way to get the mean is the frequency multiplied by the mean point for each class and add by the total frequency multiplied by the mean point of each class, then divided by the total frequency. So the mean for the labor force by age group 45 and to 49 and 50 and 54 in Kelantan was 46.85. The way to get the medium is with the sub the frequency divided by 2. Then look at the cumulative frequency where the number is and take the class and calculate together with the lower class body and class size. So the median for the labor force by age group 45 to 49 and 50 to 54 in Kelantan was 46.90. The way to get the Mohd is the class with the higher frequency count with class size and so on. So the Mohd for the labor force by age group 45 to 49 and 50 and to 45 in class was 43.79. The way to get the wage in the higher class minus with the lowest class. So the wage for the labor force by age group 45 to 49 and 50 to 54 in Kelantan was 50.8. How to get variance and standard deviation by calculate frequency, mean point and order. So the sample variance for labor force by age group 45 to 49 and 50 to 54 in Kelantan is about 2.70 and the standard division is about 15.24.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sofia Binti Abdullah and my number matrix is H2081069. Measure of position is used to determine the position of a single value in relation to other values in a sample or a population dataset. The most common measure of position are quartile, decile, and percentile. In this video, we will discuss more on quartile. Quartile is one of 3 points that divide a dataset into 4 equal groups, and the difference between upper and lower quartile is called the interquartile range. The first step is we need to find the location of first and third quartile to know its location in the class interval. After we find it, use the equation to find the first and third quartile. By using the equation, we get 35.33 for the first quartile and 59.06 for the third quartile. The interquartile range is 23.73. Shape of the distribution described by its number of peaks and by its possession of symmetry, its tendency to skew, or its uniformity. From the data, we can know that mean is higher than the median and median is higher than the mode. Thus, our shape of distribution is non-symmetric as it is skewed to the right.
Assalamualaikum and hi madam. My name is Siti Farzzanah Binti Kader Ibrahim and my matric number is H2081906. For part B, I will begin with the introduction of the data and variables involved. As seen in this slide, we had discovered two types of variables, which is independent variables and also dependent variables as well, where height is classified as an independent variable while weight is defined as a dependent variable. Next, we will look into the Pearson's moment correlation coefficient slides. Therefore, the table on the slides indicates that we only choose the first 30 selected data out of the 50 total of data samples for the calculation as well. Initially, R was known as the Pearson moments correlation coefficient. However, it must be determined or made some calculation to get the total of the x and y values equals to 5161 and 2188. And the sum of the squares of those values is 888,423 and 163,364 respectively. Lastly, the product of the value of the variable x and y is 377,144. At the end, the result of R is 0.5052 after applying the formula to the calculation instead.
My name is Muhammad RIFHAN bin ZOLKIFLI. The number metric is H201310. I want to present simple linear regression. This is data which contains height and weight. Data n equal 15. Develop the estimate regression equation. The data for all 50 students are listed in the table below. X equal to 8,618. Y equal to 3,731. X squared 1,486,312. Y squared 284,733. XY equal 643,795. This is a solution how to find R. R equal 0.2994 or 0.3. Now we go to the calculation. The formula simple variance of x as x squared equal 1 per n minus 1 x squared minus x squared per n. As x equal 3.87. Formula simple variance of y as y squared equal 1 per n minus 1 y squared minus y squared per n. So sy equal to 11.36. Next, the regression equation. This is the calculation that we get to find mean of x and y. X equal to 8,618 per 50. S equal 172.36. Y equal to 3,731 per 50. Y equal 74.62. Next, find B0 and B1. B0 equal y minus B1x. B0 equal 674.62 minus 0.881 multiply 172.36. B0 equal 74.62 minus 151.85. B0 equal negative 77.23. B1 equal R sy per sx. B1 equal 0.3 multiply 11.36 multiply divide 3.87. B1 equal 0.881. The regression equation y equal b0 plus b1x, y equal negative 77.23 plus 0.881 0.881x. Interpretation B0 equal when the height is 0, the weight is negative 77.23. Interpretation B1 equal when the height decrease 1 cm, the yield is decreased 0.881x.